Hi there. This is actually a practice by Jung Hao that will focus on how to do pulley systems. So what we have here, this is a type of pulley system that is commonly being asked. Now, what are the questions that they will ask regarding this pulley system? They will normally go for this acceleration and what is the tension in the strings. So therefore, in this example, I will talk about how you could get your acceleration and tension for a pulley system which is 90 degrees as example here. Now, to break this into steps, I will actually have my own method which actually consists of 3 steps, which is number 1, number 2, and number 3. So the first step is called the downward minus friction. Number 2 is actually F is equals to MA. And number 3 is actually something known as the cut-half method. Now, by using these 3 simple methods, you will be able to calculate your acceleration and your tension from step 2 and 3. So first things first, when we look at this question, we must be able to know that what is the resultant force. Now, when I say resultant force, I'm referring to whatever force that has going down minus off the friction here. And in this example, fortunately, we do not include any friction. Now, so my first step is, I will do a 20 minus 0 because there's no friction to give me 20 Newton. And the F equals to MA will include this force, which is actually the resultant force, to come into 20 equals to weight, the mass. The mass over here is the sum of both masses in this system. So therefore, you will be able to calculate 3 plus 2 to be equals to 5A, where A will give you a 4, ms negative 2. So this, I've already calculated what is my acceleration. As for the cut-half method, how does it work? Now, by looking at this cut-half method, what I'm going to do is I'm going to cut this into a half. So what will be resolved over here is something like this. What I will do now is that I will create the 3 kg, which is in this direction, 3 kg, where the tension of the string is moving in this direction, similarly moving in here. The tension is actually moving in this direction, and it is this direction. So therefore, for this 3 kg, the tension in the string will actually be T minus friction to be equals to MA. Now, however, in this example, I have mentioned there will be no friction. So therefore, the tension will be equals to the mass of 3 kg times the acceleration of 4, which is equals to 12 Newton. However, I have a lot of questions coming from students. They would like to ask me this question. Sir, is this T and this T equal? Now the answer is yes. Tension within a string must be equal in magnitude. So this can help me to calculate the tension in the 3 kg. However, I find the easiest way to calculate tension is actually by taking the 2 kg. Now, this is a very simple method of doing it. Now, from here I have weight and tension, which is referring to again here, which is actually 2 kg, which has a weight that acts downwards and the tension that goes upwards. I'm actually just redrawing the system over here. So my weight downwards is actually 20 Newton. I'm trying to find this Newton. Now let me ask you one question. Based on this system, you must first be able to conclude whether will this move forward or upwards. Obviously, this system tends to move downwards. So what we can do is that we will realize that this weight and tension, in order for this object to go down, the weight must be bigger than the tension. So the general rule is the bigger one minus the smaller one equals to MA. So WT, which one is bigger? W is bigger, minus the smaller one is equals to MA. So 20 Newton minus a tension, mass of 2, this is 4. Calculate this, you get back T equals to 12 Newton. So this is 12 Newton, this is also 12 Newton, and I can calculate my acceleration to be 4. So in this simple 5 minutes video, you have already learned how to do a very simple 90 degree Pulley system. Thank you very much.